Okay, so now here's another example, 1-21. Again, it says this is a linear model. That is very important. Whenever I see linear, I think of a line. I think of an equation of a line, y equals mx plus b. That's the first thing that comes to my mind. I need something that looks like this. The letters don't have to be the same, but I know it's linear. Okay, so a linear model of a diode is shown in this figure, where R sub D is the forward resistance of the diode, and V sub on, is the voltage that turns the diode on. To determine the resistance R sub D and voltage V on, two voltage values are applied to the diode and the corresponding currents are measured. That's what they're giving us here in this table. The applied voltage V sub S and the measured current I, and it's actually telling you what each one stands for in the table, are given in this figure. The applied voltage to the measured current satisfies the linear equation. This is what we're looking for. V sub S equals I R sub D plus V on. So A says, and I think that we only had to do A for this. It says find the equation for the line for V sub S as a function of I. So basically, the function V sub S is equal to I times R sub D plus V on. And what is our variable? Because they look like all variables, right? But it tells us, that's what I'm trying to show you. It tells us what our variable is. The equation for the line V sub S as a function of I means V sub S of I, where I is our independent variable, which means that everything else, R sub D and V on, are constants that we have to find. So if I is our variable, then, and we have a linear equation, where is our slope? Our slope is always going to be right here next to the variable, right? Y equals mx plus b. But we don't have an x, we have I as our independent variable, but m has got to be R sub d. So R sub d is the same as the slope, and V on must be the same as the y-intercept, because it's a constant with no variable next to it. And that will still, you can see, mimics y equals mx plus b. So again, what do we do first? Well, first we look at we have two values. We have two ordered pairs, 0.086, comma 5.0, and 0.186, comma 10. So if I have 2 points, I can find the slope. So I know the slope, which is the same as R sub D, is equal to, and again, I'll just call this 1 and this 2. So this is going to be equal to y2 minus y1 over x2 minus x1, which is equal to 5 divided by 0.1, which is equal to 50. Okay, well, that was nice. That was pretty easy. So I found R sub D, which is my slope. So now if I were to go back over here, I can fill in something. I have V sub S is equal to 50 times I plus V on. And then what do I need to do? I need to find V on. So V on. How do I find V on? I just plug in my I and my V sub S using either one of those 2 points, and I will find my V on. So for example, I have V sub S, which I'll use 5. I always like to use the smaller numbers. Sometimes I don't need a calculator, but I'm pretty sure I'm gonna need a calculator for this one even still. 50 times I. Well, I for when VS is 5.0, I is 0.86 plus V on. And so now basically this is just a calculator question from here. So I'm going to multiply 50 times 0.086 and I get 4.3. So I have 5 equals 4.3 plus V on. I subtract 4.3 and I get V on is equal to 0.7. All right, well, perfect. That means I now know the equation of the line, which is what they're asking me for. Find the equation of the line for VS as a function of I and determine RD and VI. Okay, well, RD we found to be 50. V on we found to be 0.7. And the equation for my line is V sub S is equal to 50I plus 0.7. And that takes care of that problem. And as you see, I cared much about what I'm actually applying it to. I really want you to find the math that's in these word problems. Don't get bogged down in the words. That's what usually hurts people with these word problems.